Zero. Hello, everyone. Welcome to another DevNation Tech Talk on Fridays. I'm Edson Yanaga. I'm your host today, and today I have a very special guest. Today I have my Brazilian friend, Elder Moraes, which is a developer advocate for Latin America, and he's an expert in Java and containers. And guess what? He's going to talk about it today. So let me introduce Elder. Elder, the stage is yours.
Hey, Naga. Thank you for having me. Thank you guys for being here today. I'm very happy to join you guys. So, okay. So guys, I'm especially happy today to be here and that you are here today on this Friday, where we are going to discuss Java and containers. And I will talk especially about stuff that I would like to know when I start using containers. But I hope that this content is useful for you, okay? I'm a little excited here, so maybe I missed some words. Well, when I first heard about containers, when I first learned about containers, the picture that I had in my mind was something like this. Okay, all working, all well organized, all the cranes doing their jobs on the port, all simply working. But when I really started using containers, and especially with Java, was the first times something like this. So not so well organized, not so well orchestrated. And I realized that I really needed to know more, a little more about this content, about this subject, and I will show you because in a second. Just for a few seconds here talking about me, I'm Elder Moraes. I work for Red, as Edson just said. Here is the QR code for my channel on YouTube where I share content both in Portuguese and English. I am a Brazilian. In weekly, I share some content in English and Portuguese about cloud native, about Java, about containers, about microservice. So if you would like to know more about it, you can just follow this URL or scan the QR code and subscribe it. I'm a board member at SoJava, one of the biggest jugs of the world. I have just published the second edition of my book. It's the Jakarta EE Cookbook. And my mission here at Red Hat and my mission as professional is to help you developers to learn more, to deliver, to build applications that are awesome so I can help you to work on a great project. So that's my mission here and I'm very happy with that. Well, let's go ahead. When you work with Java and containers, there are some issues, there are some subjects that you need to take care, that you need to realize before using it. And we could talk a whole day about it, but I will just have half an hour here and I will approach some of them. The first is the long build time. So if you not take care of some specific issues that you could create when building your images, you can take long build time when building your image, for example. And why it is an issue? Because today we are creating pipelines, we are creating automations, and we are not just delivering applications itself. We are delivering applications inside containers. We are delivering images. So these images will be deployed on a cluster, on a Docker, on another machine or whatever. And as huge, as bigger is this image, for example, it will increase the build time and it will increase the time of your pipeline. So you need to figure out how can reduce this build time. And as I just said about the image size will impact directly on the build time and it will also impact directly on the deployment time. So you needed to try to reduce the image size as much as possible. Another aspect is maintainability, because you will not maintain your application. Now you need to maintain also your image, the image that will host your application. So how can we easy the way that we manage the maintainability of our images. And the last point of our session today is resource allocation. That especially for Java, you need to take care in order to be successful. I'm not saying that Java will not work. At the opposite, Java works pretty well with containers, but you need to do it right, and that's what we're going to talk today. Okay, so first topic here, we are going to approach to long build time, how to avoid long build time. Okay, I forgot to start my timer. I will just do right now so I don't miss the time here. Okay, build time. The most important thing that you will need to think when you are thinking about build time is caching. And why? I don't know how much you guys know about containers, but let's talk about Docker, for example. When you are using a Dockerfile, we will talk a lot about Dockerfiles here today. When you are working with Dockerfiles, each line of a Dockerfile, Docker will create a caching for that line. So the order that you put each line matters for caching. Especially the whole concept here is whatever change at most you put in the last step, and whatever change not so frequently you put in the top. Okay, so for example, if you do this, if you put your application in the first lines of your Dockerfile, your application is what changed the most on your Docker image. So anytime that you build this image, you will break the cache here, and once you break this cache, you will break the whole cache of your Dockerfile. So you need to put your application in the last steps of your Dockerfile, because these steps will not change so frequently as your application. So the order matters for caching. So mind the order of your comments, of your whatever you do in your Dockerfile, put whatever change more times in the last steps and whatever change less times in the first steps. Another aspect for caching is to be specific. Okay, so instead of just copying using stars like I did here, you should copy the file itself. Okay, I should do the same for this guy here, but we'll need to put dozens of lines. So, but for this file, I need to copy Quarkus 1.0 and whatever to this folder, not star runner. Because if for an accident or for some changes or whatever, I copy another file to this folder, name it as runner in the end, I will break the caching for this line unnecessarily, for example. Okay, so if you need to save the cache of a Docker, you need to be specific when copying files. Another stuff for caching is group units. Okay, so for example, here we are running run apt-get update and run apt-get install. Instead of doing this, you should group this command, because I will create one unit here of command, and this will have one cache. And as we said before, this don't change so often as your application. So if you put this one in just one cache, you will save space of caching. So your cache for this Docker container will be much more efficient than if you use this. Okay, so group units when using commands inside your Dockerfile. So here we approach it about time, long build time. So basically here we're talking about caching. So caching is your lifesaver when talking about build time. Okay, now let's learn how to get rid of huge image sizes. As I told you in the beginning, the image size, the size of the image of your container matters a lot, both for build time itself and also especially when you are deploying. When you are putting your application inside your pipeline, the image size is very important. So the first thing that you need to know to reduce the size of your image is getting rid of unnecessary dependencies. Okay, so for example, when we are dealing with apt-get update and installing or whatever, there is an option on apt-get that is no install recommends. Because when you are using the last Y here, it will install automatically all the recommends for those packages and applications that you are installing. But if you use this guy here, you will save a lot of space, a lot of size of your image. And and this guy. So you should really getting rid of unnecessary dependencies when installing this guy here. And another aspect, of course, here we are installing SSH and VIM. And why would you need? Okay, sometimes maybe you need, but it's better to, by default, to not have SSH, VIM, or whatever other tool. And if you need, you go ahead and install for some debugging or whatever, and then you remove. But by default, keep on your image just the package, just the application, just application that you have, the software that you have that you really need. Okay, so don't install stuff inside your image that you really don't need. And as we are talking here about installing packages, about updating and so on, when you run the apt-get update and install, you have the cache of the package manager, not the cache of your container, but the cache of your package manager. Okay, so in the same command where you are running the installing and the updating, you should also remove the cache. Okay, so instead of just using this guy, you should add another. Remember the group unit? We just added another line to the group unit to remove our cache of our package manager. Okay, and of course, beyond making your base image smaller as possible, you should also use optimized tools and frameworks, because it's not only about your image, it's about your application also. So if you have an image with 100 megabytes and your application has 300 megabytes, 400, 1 giga, you should find ways to also reduce your application. And by using tools that are optimized for this, you will be more successful. And of course, when we are talking about Java today, we can use Quarkus that will make your Java application subatomic, because they will make your Java application really as small as possible. And if you are using an application that can be used as a native image, you can use GraalVM. And luckily, when you use Quarkus, you can use both, okay? Because Quarkus uses GraalVM to also generate native images and in a very simple way, okay? So both Quarkus and GraalVM can help you to also decrease the size of your container image. All right? Okay, so it's not just about making our image being constructed, being built as fast as possible, and it's not just about making our image be as minimum size as possible, but also we need to maintain, because our application will evolve, our application will have new features, and the technology will evolve, so we need to make it easier in the life cycle of our application. So how we can stay away from the hard maintainability. And the first step that you should follow is to use official images. So far we've been using here from Debian and running the update and installing and OpenJDK and so on. But guess what? We have official image, OpenJDK. And why it is important to use official images? I can talk about Java, okay? I can't talk about other languages, but for Java ecosystem, we can, in most cases, rest assured that if we are using official images, we know that images are following the best practice the guys that are maintaining those images are following a lot of good practice to decrease the size, to increase the build time. So all the stuff that I just talked to you until now, if you are using official images, maybe, and I'm almost sure about it, they are following the same steps. Okay, so you are already starting your base image with best practices as possible. So when possible, and try as hard as possible, use official images. And as you just use official images, one step further, be specific with tags. And I would say the same not just for containers, but your application itself. Because many times people use the latest tag. And the latest tag is very dangerous because it is replaced all the time. It's hard to roll back some version if you have some problems. And especially here for containers, if you are relying on the latest and the people who are maintaining the base image change it, the latest, and maybe it can introduce some bug on your application. Maybe the client that is using that version will break or something like this. So for the sake of both maintainability and stability, you need always to be specific with tags. Okay, so I'm using the version 8. So once I'm ready to move, or I need to move to another version, I will go ahead and change the tag so we can maintain our image stable and know what's happening. Okay, not just praying to be stable and praying to not change our version. Okay. Another aspect for image sizes is choose minimal size images. Okay, here I have a comparative between OpenJDK 8. If you are using just plain 8, it's a 500 megabytes image size. And if you are using the Alpine, is the shorter one, is the 85. So it's almost 500, almost 400 megabytes of difference. Okay, and you should always try to go in the first place to the minimal image size as possible. And if you need something that is not here, then you jump to this one with 185. And if you need something that in this one, it's 200, okay. And if you need the whole JDK, okay, you go to the 500. But usually when people just look to the version and start with this 500 megabytes, guess what? Your application is not even here. So you are starting with 500 megabytes and you still don't even have your application, okay? So try as hard as possible to go to the minimal size images so you can save a lot of space of storage, of traffic on your network, in your clusters, etc. Okay? Many parts of this presentation so far I got from this reference. I will let this presentation available for you so you can read and see a lot of other tips for you. And now we are looking for resources management, resource allocation. As I told you in the beginning, when we are dealing with Java inside containers, we have some aspects of resources allocation that really needs to take care. So let's see. And if you are using Java 8 update 121 and before, and if you look for a few seconds to the last surveys, you will see that around 60 to 80% of the Java developers around the world are still using Java 8. So it is still important to talk about it. So if you are using 121 and before, Java and the JVM simply don't know, is not aware about containers. And because something called C groups, okay? I don't know if you know about it, so I will just talk briefly. C group is a kernel, a Linux kernel feature that limits and isolates the CPU, memory, I/O network for one or more processes. In other words, a container is a process inside the host. And this process has network, CPU, memory, and so on. And these processes are allocated, these resources are allocated to this process. But when you have a JVM inside a container, JVM was, until Java 8, was still looking to the resources in the host. Because remember, Java is 25 years by this year. And containers, like Docker containers, for example, has 6, 7, maybe years. So when containers came to the market, to the field, Java was already there, and containers came with a new concept, kind of new, because DC groups was used for a long time inside Linux systems. But this new world for Java was needed to be absorbed, and it was not done in the first step, in the first times. So, for example, as Java wasn't aware about the resource that was allocated just for containers, in the first, remember that I'll show you the boats messing around in the first slides. That's why we had these first problems with Java inside the containers. Okay, so I would say if you're using Java 8, do not go with containers, but if you need, and some people really need, one option that you have is to use this kind of hacking made by the Fabricate guys. So they created this, I just took a small portion of the file here, but they created a script file to run inside your container, and this script will help the JVM run inside the container to get the right information, the right resources information, not the information that are coming from the host, but the information that are coming from the container itself. Okay, on Java 8, update 131 and Java 9, we got some updates, we got some improvements. So now we have a flag that will help to limit the CPU use of container, these parallel GC threads. Now we have an option, another flag, that is to limit the heap based on the C group, not on the host anymore. And we have also another flag that where you can allocate a fraction of the run. Not, so not 100 megabytes, 200, but a fraction, 25%, 10%, 50%. So based on the percentage, not as a number itself. And in this version, all those flags were experimental. So if you are using, be aware, they were experimental flags. For Java 8, 191, and Java 10, all those flags were deprecated, and we have 3 new ones also based on percentage, but now we have the initial, the max, and the minimal. Okay, so we can have more power of configuration over the RAM allocated for containers. And then now we have also the number of CPUs allocated for a container. For a container, it's based on the container by default. Because before this version, if you are running a Java application inside a container, you needed to really configure to do the math, to do the calculation based on the container. And by that release, and we have here the real number of the JDK release, it's done by default. Okay, so if you just put your Java application inside a container, it will just calculate based on the container by default. For Java 11, we have more improvements. Now, this flag shows settings, the container metrics feature, display the system or container configuration. Okay, so it's the application is inside a container, it will show the metrics for the container. If it's running on a JVM inside another host, it will show the system resources. And this release of JDK improved again more improvements for CPU calculation for both containers and hotspot. And we have here this another flag where you can give the preference for containers or for hotspot. On Java 12 and 13, we have this tool here. If you don't know, it's generates NCDB. It's a tool where you can debug crashed JVM. You can take the core dump of that crashed JVM and debug it. Now you can attach it to this tool to a container, okay, to a Java process running container. And we have support improved for Java Flight Recorder. Java Flight Recorder is a tool for profiling, okay? And now the systemd slice memory also was improved, okay? So that's feature inside the Linux that will manage a lot of resources for your user and for the process is improved for memory slice. And in Java 14, just a few months ago was released, we have the flight recorder event streaming. So now you can expose the flight recorder data for continuous monitoring. So for example, if you are running your application, your Java application using Java 14 inside a cluster, for example, you can try to attach some Grafana, some Prometheus and other observability tools in order to getting those data and have a better management. And we have a new incubator tool that is the packaging tool that's made to package self-contained Java applications. Okay, so maybe in the future it can help also to package Java applications inside containers. All right, so we have some conclusions here in the end. So yes, Java and containers can get along, can be friends, can live together and be very successful. You need to be and you should be very intentional when building your Docker files, okay? So don't just go ahead and start throwing commands and throwing files and throwing whatever inside the Docker file. So know what you are doing, pay attention to what changed most, what changed less, pay attention to the tags, to the versions, use official images when possible. Okay, so be very careful when building your Docker files because it will follow your application in its whole life cycle. It's better to start with Java 11 because Java 11 is the latest LTS version, and also because with Java 11 we have serious improvements for Java running inside containers. They started doing better with Java 9, Java 10, but in Java 11 they are pretty good. Okay, and if you really need Java 8, and I would ask why, but I know that if you need, you know why. Okay, but be extra cautious. Okay, so if possible, use that hacking from FabricH or trying to really take care of all the configurations, whatever you can do in order to avoid some serious problems. Okay? And just for finishing, I would like to let this URL for you. It's from the Red Hat developers. I have the QR code and the URL. You can subscribe where we can provide you a lot of content about Java containers, Kubernetes, DevOps, CI/CD, and cloud native and other related content to help you, as I said in the beginning, to be successful on your project and your career. Okay, so Yanaga, I don't know if you have questions.
Hello, Elder. Thank you very much for this very informative session. And actually, I was aware of some things that we could do with Java containers in Java 8 and 9, but I didn't know. So it was very nice for me because I was able to learn that you have newer things in Java 10, 11, 12, 13, 14, which means that Java is always getting better to run on top of containers. We didn't have any specific questions on the chat. Which might be a good thing because you provided like a lot of insights about how we should be running Java inside containers. But James did made a comment about Podman. I don't know if you tried Podman before to build and run your containers.
No, I never tried, but I heard that's very helpful. But
It's a very nice tool that runs on Linux. So if you're running on Linux or if you have a VM on Linux, I can recommend that. You should be trying. And a comment just appeared here. Let me see what it. Yes, Adrian Coley is saying that if you have build packs for building your Docker images, you don't have to worry about all of this stuff like creating your Docker files. But I think that the good point is that if you're using build packs or if you use OpenShift SUI, for example, somebody took care of that for you already. So it was either the build pack team or the OpenShift team for example. So I don't know, would you recommend like developers doing it itself or using a tool in a software deployment pipeline to apply those sets?
Yeah, whatever you have, you can have a tool to help you, of course, is better. But we also know that a lot of people need, for whatever reasons, to still use that Dockerfile. So for both cases, we need to take care. So if you need to use Dockerfile, you need to follow some best practice.
Perfect. Well, thank you very much, Eddie. Elder, DJ Matt is saying here, very helpful presentation. I agree with him. It was very helpful presentation with lots of content. And also, I hope that everyone that was watching here just enjoyed it as much as myself. Thank you very much for being here with us in this DevNation Tech Talk on Friday, and hope to see you again next week. Bye.
Yeah. See you guys. Bye-bye.